Hey everyone, how are you all doing? Well, in today's video, let us cover basics of sets. If you're moving from class 10 to intermediate first year, then it might seem very hard to grasp the concepts. Firstly, let's understand the basics of sets. Well, in today's lecture, let us discuss what are sets, properties of sets, forms of sets, and types of sets. Well, there is a vast difference between forms of sets and types of sets. And in the next video, let's discuss about the subsets, the properties of sets with subsets, and so on. What are sets? Now, a set is a collection of well-defined objects. Now, let me take an example over here. Let us take a box and compare this box with set. All right, I'm telling that this box right over here is a set, and this box contains some sort of elements in it. In the same way, a set contains elements in it. These are known as elements. Now, I'm sure you must be wondering that a box can be empty. Can a set be empty? Well, that is definitely possible. A set can definitely be empty. If it does not contain any elements, then it is known as an empty set. Alright. We generally represent sets by using curly brackets or flower brackets. Now, if I say there is a set A which is equal to, here I'm going to put the curly brackets and whatever the elements that are present in it. Let's suppose say I have 1, 2, 3, 4. These are the elements present in my set, right? Then I represent the set in this manner. Now let us move on to the properties of sets. Firstly, we have sets are denoted by capitals. That is, if I have a set A which is having 1, 2, 3, let's say. Here, the A that is there is denoted always in capital letters. Alright. Now you're not going to write B is equal to here. This is a small b. That is not going to happen. You're going to put on the capital letter. B is equal to 1QP. Anything like that. Alright. Now that was property 1. Moving forward, we have elements in sets are small letters. Now if you observe over here, I have nowhere written QP in this manner. Right? I have always represented it in small letters. So elements in sets are small letters. That is, let's suppose say I have X is equal to I, J, Y. Alright. Now this right over here means that the elements that are there in this set, they are small letters. Alright. Moving forward. If A is an element of set A, then A, what is the symbol over here? It is read as belongs to. Alright. If A is an element of set A belongs to A. Now what does this mean? Let's say I have a set A which has A as its element and few other elements as well. Now this means that A is the element of A. What does this mean? It means that A right over here belongs to set A. Alright. Now in order to avoid confusion, let's put on this as X. Then it means that A over here belongs to set X. Now these were the three properties. One more thing that we can note over here is the number of elements. How do we know that there are a certain number of elements in the set? Let us move forward and discuss that. Now this right over here seems to be very important. If you recognize the number of elements in the set, that is when you will be able to understand the roster form and the set builder form that we are going to discuss in a few moments. Alright? Let's suppose say I have set A. I'm going to increase the level one by one. A, B, C. Now you might tell me that there are three elements in this, right? One is A, one is B, and one is C, isn't it? Let me write this down over here. A is one element, B is one element, C is one element. Alright, this was too basic. Let me increase the level over here. Let me say B is equal to, in flower brackets or the curly brackets, whatever you call it, I have alpha, beta, gamma, phi. Now tell me, how many elements are there in this? Well, if you're wondering, it is the same. Same way you're going to calculate the elements. You have four elements. They are alpha, beta, gamma, and phi. This right over here is phi. Alright. Then, let me tell you, C is equal to alpha like this, right, in curly brackets. And then I have alpha, beta. And then I have A, and that's how my set is. Now tell me how many elements are there. Well, everyone, do not get confused. Whatever is in the comma, that is one set. That is one element, I'm sorry. Right? This type over here, that is alpha in curly brackets, can be one set. Isn't it? Now, in previous example, we have discussed about the box that is there. In the box, there can be various other boxes as well. That is, in a set, there can be various other sets as well. And that sets that are there, they can together form an element, right? So this right over here is one element. And this over here is one element. And this over here is one element. Here, this one is one set, which is enclosed by another set, which indeed contains another set. Another set contains this element. Alright, but as a broader view, we consider this as an element. Alright, so how many number of elements are there in this particular set? There are only three elements. One is this one, the other is this, and the other is this. Alright, this is how we find out the elements in the set. And one more thing that you need to keep in mind is elements do not repeat in a set. That is a very important property that you must keep in your mind. Let me write this down over here. Elements are not repeated in a set. Now what does that mean? You cannot write A is equal to AAB. No, you cannot do that. Here A cannot be written twice. Now even if it is written like this, it does not mean it is not a set, alright? It means that it is AB only. Alright? Even if by mistake also it is written in this manner AAB, it means that it is AB only. It means that it has two elements only. Alright? But make sure that elements are not repeated in the set. Moving forward, we have the forms of set. Now we have two types of forms of sets. One is the roster form and the other is the set builder form. Well, if I need to talk about the roster form, it is the simplest form of a set. Now if I have set A, which has A, E, I, O, U. Now this is my set A. Now if I need to say, what is the set builder form then? Roster form is the simplest form. Now what is the set builder form? Set builder form expresses things in properties. Now what do I mean? Do not get confused. Here I have an example. The same thing we are going to write it in the set builder form. Alright, how do we do that? Now here I'm having the curly brackets itself. Now I'm going to write x such that x is an oval. Now what does this mean? X right over here represent element, and this does not mean is to or something that you call. It means such that. So x is such that x is a vowel. Now x can only be a, e, I, o, u, right? X will be only equal to a, e, I, o, u. That means here the set builder form is a complex form where it is undergoing some properties in it, and it means the same thing, right? But here the properties are told. Fine. Now x is to x is a vowel. Here is to is nothing but such that. Alright, x such that x is a vowel. That means x can only be a, e, I, o, u anywhere in the universe. Right? So these are the two forms, that is a roster form and a set builder form. Let's move forward. Now we had such a easy form, that is the roster form. Now what is the need of a set builder form then? Now everyone, every time the data cannot be simple and small, or a very little amount of data. Let's suppose say I have 1, 2, 3. That is a small amount of data that can be represented in the roster form. But if I say a is equal to, I need to write from 1, 2, 3, 4, 5 till till 10,000. Now I can't keep on writing this and waste my time. And that is why set builder is there. Set builder can be a complex process to convert from a roster form to a set builder form, but that means here the set builder is actually helping us to write a lot of amount of data into simpler ones. Alright, now how do I do that? If I need to convert this 1, 2, 3, 4, 5 till 10,000, let's suppose say I have a is equal to, I'm building a set right now. Here I'm going to write it as x is to, x belongs to natural numbers where n is equal to 1, 2, 3, so on till 10,000. In this way, I represent this data in the set builder form. It has been completed in one statement. But what if I need to write it in a roster form? Then I need to keep on writing till 10,000, right? That will eat away my life, right? In the same way, over here, what is the use of set builder form? In order to convert a lot of numbers or a lot of data into a limited form or a simple form, that is the use of set builder form. Now let me discuss a simple question with all of you. It might be confusing at the first, but later on you'll be able to get it. Now if I say x is 2, x is a letter of the word numerous. Now this is my set builder form. Alright, now I have few options right over here where it will be available for you in the roster form. You gotta guess it right. Now this right over here displays you the 4 options. Now you should keep a note of the properties as well over here. Alright. Now here x is a letter of the word numerous. Alright. Now if you look over here, N, N, U, U, M, M, E, E, fine, R, R, O, O. But this right over here, U is still there. Here also it is there. But here, U is represented 2 times in a set. That cannot be possible. So option A is definitely wrong, isn't it? Now if I move on to discuss about option B, I have N, U, where is U? U, M, M, E, E, R, R, O, O. U is again there, so here it's already represented, right? S, S. This is the correct form. So this is your right answer over here. But still, let us move on to discuss the next options as well. Here, N, U, M, E, R, O, U. Why is it repeated twice? And here, why is X written? X is nowhere a letter in numerals. Right. And none of the above is definitely not the answer. So what is the answer right over here? It is option number B. Make sure you know that elements in the sets are not repeated. Okay, that can make a huge difference in your answer. Now let us discuss another question for clarity. Here let me say x is to x square plus 7x minus 8 equals 0, where x belongs to real numbers. Now r over here is not rational, it is real. Alright, fine. Now everyone, the thing that you see on the screen over here, it is a quadratic equation where if you solve this quadratic equation, you get the value of x, and that is the, the two values that can be returned, returned in the roster form. So x square plus 7x minus 8 equals 0. Let's solve it first of all. Here minus 8, can I write it as minus 8 into 1? Well, I'll not write it as minus 8 into 1, but I'll write it as 8 into minus 1. So x square plus 8x minus x, okay, minus 1x or x minus 8 equals 0. If I'm going to solve this, I'm going to have x into x plus 8 minus 1 into x plus 8. Can I write it in this manner? I can definitely write. So this right over here will become x is equal to 1, comma, x is equal to minus 8. Now 1 is a real number, minus 8 is also a real number. Any worries? No, right? So what is the roster form? The roster form will be C is equal to, in flower brackets, 1 comma minus 8. Now this is the roster form, whereas this is the set builder form. Well, need not worry, we will solve a lot many questions in the next video. Now let's discuss the last topic for today, that is the types of sets. Now we have the first one as the null set, empty set, or the void set. It has 3 names. Alright, now if I need to talk about this, a set or a box with no element is known as a empty set, null set, or a void set. It does not contain any element. Alright. Now it is denoted by phi. This is phi over here. Phi. It is read as phi. Alright. Now what does this mean, denoted by phi? If I have a set A which does not contain any element, I'm going to simply write down phi, which makes the viewers understand that this is an empty set, a null set, or a void set. As simple as that. Let's solve a quick question. Here A is equal to x such that x is a real number. X square is equal to 9 and 2x is equal to 6 equals. Now here, assume in mathematical languages from now on, consider and as simultaneously. Make sure you pause the video and find out the answer first. Alright, now let me tell you what to do over here. X square is equal to 9. That means the value of x is plus or minus 3. Right? And here 2x is equal to 6. X will be equal to 3. Now everyone, here and means simultaneously. That means x should satisfy x square equal to 9. On the same manner, it has to satisfy 2x is equal to 6. Such an x is 3, isn't it? Minus 3 cannot satisfy 2x is equal to 6, isn't it? So, my right answer is going to be option number A. But here, let us not miss the concept. Have a look at this question now. Here, what are the edits that I've done? Everything is same except this. 2x is equal to 8. Now tell me, here the value of x will be definitely plus or minus 3. Here, the value of x will be 4, isn't it? Now tell me, what will be my new roster form set? What do you think it is? Well, let me tell you that it is option number A. Now this letter here means it's an empty set. Why is it an empty set? Because it should satisfy both the equations over here, that is x square is equal to 9 and 2x is equal to 8. But here none of the x values actually match in real, right? So it is an empty set. So it is option number A, where in curly brackets you have 5. That is our concept where we discussed about null set, empty set and void set. So the questions are not going to be direct, but they're going to be a cluster of all the topics. Moving forward, we have the singleton set. The word itself says it is single. That means there is only one element. Now, let us take infinite number of examples. There are many, isn't it? They are very, very easy. Here, let's suppose say I have this. 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 All of these are singleton set. Now, definitely, any one of you might have a focus on this. Now, you might ask me, how is this a singleton set when it is an empty set? Now, everyone, here phi itself can be an element, isn't it? Am I right? So this is a singleton set where there is one element. So such sets, this set can be either empty set or a singleton set. Fine. Phi can itself be one element, or phi can be used to represent an empty set. So that is what it is. So here it can, if suppose there is a set like this, it is both an empty set and a singleton set. Alright. Here we have the finite set, which means there are a finite number of elements. Alright. Now what do I mean by that? When we discuss about infinite set in the next slide, you will be able to clearly differentiate them. But still, let me leave this slide with a good example. Let's say 1, 2, 3. This is a finite set. There is an ending for this set, isn't it? So that is a finite set. Do not worry, let's discuss. Here we have the infinite set. Infinite set means if suppose I have 1, 2, 3, I put on a so on symbol like this. This is an infinite set, right? Here it can be till any number, right? Here I did not mention any number. So yes, it is an infinite set. On the other hand, in the previous slide I have mentioned A is equal to 1, 2, 3. That's it. I have mentioned a fixed number of elements, that is 3 elements are there. Here I do not have a clarity that how many elements are actually present in the set. That is the difference between an infinite set and a finite set. Alright. And here one thing that I want to notice, a finite set can be empty as well. Now why do I say that? Well, if I say A is equal to 5. Now this is both an empty set, a finite set as well, and definitely a singleton set. Now why do I say it's a finite set? Because there is only one element and it is limited to that space, isn't it? So this is a finite set, singleton set, empty set, isn't it? Now we have an interesting one, that is equal sets. Now what do I mean by equal over here? Equal means same. Right, in a layman language, I'm calling it as same. Why do I say that? Let us say A is equal to 0, 1, 2. This is one set. If I need to find out a equal set for this, I'll write B is equal to 2, 1, 0. What does it make a difference? All the elements are present, isn't it? Right? So these are equal sets. They may not be of the same order, but definitely the order can differ. Let's suppose say C is equal to 0, 1, 1, 2. This is also an equal set for these two. Why? Because here 1 is repeated twice. That does not make a difference. It simply means 0, 1, 2. And that is the same as this and this. Alright. That is a equal set. Alright. Where the elements are same. Fine. Now here it means that A equals to B equals to C. That is what it means. Now tell me what equivalent set would be. Well, here I'm gonna introduce you all to a hefty term, that is cardinality. What is cardinality over here? Now cardinality means the number of elements. Before I even talk about equivalent sets, I'll first talk about cardinality. The number of elements is known as the cardinality. Now what does that mean? A is equal to 1, 2, 4. Alright. Now here how many elements are there? 3 elements. You'll tell me there are 3 elements. Now I'll ask, what is the cardinality of this set? Then you should say it is 3, because the number of elements are 3. Alright. Now I'll say B is equal to 1 alpha beta. Now you'll say the number of elements are 3. So cardinality is 3. Fine. That was the topic of cardinality. But it has a lot to do with the upcoming topics. It isn't as simple as what it actually seems like. Now if I need to talk about equivalent set, it means here the cardinality is same. Now I'll say A is equal to 1, 2, A, B, C. Now here my cardinality is 5. Put this aside. Let's say B is equal to A, B, C, D, E. Now I'll ask you if these two sets are equivalent. Now you'll say definitely they are equivalent because their cardinality is same, isn't it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So since their cardinality is same, they are equivalent sets. Now, well, that's the end of this basic video that we have covered today. Make sure you hit the like button, share and subscribe. Thank you.